Okay, FFA kids and Kellen and that's it. Okay, those guys. 4 of them. Megan, Jack, Hallie, and Kellen. All right. Here are the 2 problems these are the at least 1 problems. These are the ugly ones that I want you to put on the back side of this sheet. This is your cheat sheet. This has all your formulas on it. And we're going to put the at least 1 problems on the back side of here. So if you need to pause, go ahead and pause. But here is this, all right? This first one is a little more simplified than the second one. Second one's a little bit harder, right? But the first one is you are having 4 children. And I want to know the probability of me getting at least 1 boy. We are assuming that boys and girls have 50-50 shot, right? Okay. So if we start listing options, I'm not going to list them all out, right? I could have all girls, right? I could have a girl, a boy, a boy, a boy. I could have a girl, a boy, a girl, a girl. Like I could have a bunch of different combinations all the way down to all boys. Boy, 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 right? Okay. All of those. Like boy, 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 girl, right? And there's a bunch of them in between, okay? So find the probability of having at least 1 boy. If I'm looking at all these combinations, every single combination is going to have at least 1 boy, right? This one has at least 1 boy, this one has at least 1 boy, this one has at least one boy, right? Except for one of them, which is this one, right? Okay? So what we do when we're looking at least 1 is we do the opposite of at least 1. What's the opposite of at least 1? Yeah, the opposite of at least 1 is none, right? So I'm going to do the probability of no boys. Okay, that's what we're going to find first. Not at least 1 boy. We're going to find the probability of no boys, all right? How many kids are we having?
4.
1, 2, 3, 4. All right, what's the probability that the first one is not a boy? 1/2, right? I have a half chance that the first one's not a boy. What's the chances that the second one's not a boy? 1/2. Third one, not a boy. 1/2. Fourth one, not a boy. 1/2. 1/2 times 2 times 2 times 2, right? That'd be like 1/16, right? 1/16. So the probability of me getting no boys is 1 out of 16. That means there was a list of 16 right here, and there's only 1 combination that is not boys, right? So what's the chances of me getting at least 1 boy? Probability of at least 1 boy is 1 minus 1/16, which is 15/16. There are 15 out of the 16 combinations that will have at least 1 boy. Does that make sense? Yeah. Okay, we always do that. When we're looking at least 1, we do the opposite of that, and we subtract it from 100%, or subtract it from 1. Clear as mud? Not too bad? Okay, you do the opposite. The opposite of at least 1 is none. I have 4 kids, yes.
You only have 1 boy?
And I only have 1 boy. Yep.
Do you want more?
Do I want more?
Would you want another boy? Like, did you want another boy?
I always thought I wanted a boy first, and God knew I shouldn't have gotten a boy first. I think I can only handle 1 co-mature boy. Yeah. I think he knew what he was doing. Yeah. That, and I feel like when they are older, you're always closer to your girls than you are to your boys. So like, I don't know. Not that, whatever. I don't know. Anyway, at least grandkids, like I'll be closer to my girls as grandkids than probably my boys' I don't know. Maybe that's not true, but okay. All right, good. Number 1, not so bad. Now we switch it up a little bit, all right? The probability, and writing down facts are your friends, right? Facts are your friends. When you're reading this problem, write down information. So the probability of an alarm clock working is 90%. So I'm going to say probability of work. This alarm clock working is 0.9. That means the probability of fail is what? 0.1. That's not a very good, reliable alarm clock, right? That means 1 out of 10 times that you set your alarm, you're going to be late and you're not going to wake up to it, right? Okay? Your alarm clock only works 90% of the time. So, as a result of that, we're going to use redundancy. That's this thing. Redundancy. Okay, that's the process of using multiples, right? So we did 3 alarm clocks. I'm going to set 3 of them. And what's the chances that at least one of those 3 are going to go off? Maybe all 3 of them go off. I don't know. Maybe only 2 of them go off. Maybe only 1 of them goes off. But at least 1 of them is going to work, right? Now, this is a little bit harder because it's a 90% chance and a 10% chance, right? Okay, so if I only set 1 alarm, I have a 90% chance of waking up. If I set 2 alarms, it's going to go up a little bit higher than 90%. If I set 3 alarms, it's going to go up even a little bit higher than 90%, right?
So why does it go up if it's still 90?
What do you mean?
Why does the chances of it going off go up if it's still 90? Like,
Because now you have 2 of them. So like I could have, if I set 2 alarms, right? I could have this one work and this one work. Or I could have this one work and this one fail. Or I could have this one fail and this one work. Or I could have this one fail and this one fail, right? Like these 3 combinations are still gonna allow me to wake up on time versus this one doesn't, okay? Whereas before, it was work or fail and I only had 2 outcomes, right? That makes sense? Okay, so I have a little bit better of options when I have 2, but now we're doing 3 of them. So I wanna find the probability of at least 1 working. That's what I'm trying to find, all right? Now, the only way that at least 1 of them is not going to work is if all of them fail. So probability of, I'm going to do 1 minus the probability of none work, right? You always do the at least 1, the opposite of at least 1 is none, right? So I'm going to find the probability of none. We have 3 of them, 1, 2, 3. What's the chances that this one does not work? 0.1. What's the chances that the second one does not work? 0.1. What's the chances that the third one does not work? 0.1. If I multiply all those 3 together, I get 0.001, right? And I do 1 minus 0.001. So now I go from 90% chance of being woken up to, if I have 3 of them, 99.9% chance of being woken up. Is that what 1 minus 0.001 is?
999.
Yeah, 0.999 or 99.9%, right? Does that make sense? Okay, so redundancy really helps out because like it increases my chances, right? But every single time they say at least 1, you're going to do the probability of none, right? None working. What's the chances that none of them work, right? Set up the 3. Figure out what that is, right? Make sense? Okay. Let's go to your homework assignment. Your review, not your homework. Your review. And let's see, are there any at least 1 problems on this one? I want to do that if we do. At least 1.
Can we turn on Hocus Pocus? Yes, we can.
Find their job chosen within a certain.
I mean, Tim, have you watched that stuff at all? Sweater.
You wash every day, yeah. You're supposed to. Sweatshirt, no.
Okay, go to number 19.
Bro.
Go to number 19. Okay? On the review, number 19 is kind of like this problem, and it's a big, long problem. Facts are your friends. Write down all the facts out of this paragraph. Here we go. A stats student plans to use a TA84 Plus calculator. That is one of those graphing ones. TA84 Plus, that's the big honkers that graph stuff, okay? From past experience, she estimates that 92% of the time the calculator will work. I know a student, Austin Strasberg. Do you guys know who Austin Strasberg is?
My cousin.
Yeah. He went and took the ACT and his calculator died like 5 problems into the math part of the ACT. And he was like, oopsie doo. And he had nothing. He didn't have a backup or anything. He had no backup batteries or anything.
Probably got like a
Yeah. So he was like so bummed because he's like, oh, the other section, this was before they did your super score, right? All the other sections he was like rolling on, like math was like the last section. He was like, I did really good. Like I have a chance to have a really good composite this time. And then his calculator died. And I was like, no. He came and told me that the next Monday. I'm like, no. Okay, so 92% chance that, I don't even know. I don't even remember. It wasn't as good as what he probably could have if he had a calculator. So 92% of the time the calculator will work. So probability of work is 92% or 0.92. I'm also going to put down the probability of fail. What's the probability of fail? 0.08. Okay, facts are my friend. I'm going to write those down. Because, I'm right here. Because the final exam is so important, she plans to bring 2 calculators in case one loses power. Does she gain much by bringing a backup calculator? Use the probability that she'll be able to complete her exam with a working calculator. Okay, so if I look at this last sentence, use the probability that she will be able to complete her exam with a working calculator. That is finding the probability that at least 1 will work.
So you take
Does that make sense?
times 2.
Okay,
Or 0.08 times 0.08.
right. So if we're doing this, probability that at least 1 works I'm going to do 1 minus the opposite of that, which is the probability that none work, right? Okay, so the probability that both of them don't work, the chances that the first one doesn't work is 0.08. The chances of the second one doesn't work is 0.08, which is 0.0064, I believe, right? If I do that, okay, 1 minus 0.0064 brings my chances to 99.36%, I think. So I go from 92% working to a 99.36% chance that both calculator, or at least one calculator will work, right?
I would take the second.
Would you take the second one? I would. Yeah, that increases your chances a lot. Does she gain much by bringing the backup calculator? Yes. Bring the backup. Okay, so every time they ask for at least one, do the probability of none and subtract from 100%. Good, good? Yeah, yeah? Yeah, yeah?
Yes.
Let's do 20 just to round it off.
Oh my God.
Because we're right here. Okay? An author has 6 different books in print. Okay? 6 sounds like a total number, and usually we use the letter what? N. If those 6 books are stacked in a random order, what is the probability that they are arranged in alphabetical order from top to bottom? In alphabetical order. So, we are using the 6 books, and actually we're putting all 6 books in order. So my R is the same. I'm stacking all 6. Now, does it matter
Yes.
what order they go in?
Yes.
Yes, alphabetical order will be different, right? Okay, so we can do either 6p6 or we can do 6 factorial, either one. That is 720, I believe, right? So what is the chances of them being placed in alphabetical order exactly?
Over 7.
1 over 720, but that's not the final answer because that's only one of the answers. Alphabetical order from top to bottom. How about 7 different books? So now what do we do instead? Now we're doing 7p7 or 7 factorial, which is
1 over 5 or 50, 40.
5040, right? Okay, the probability 1 over 50, 40. So it increases my chances like decreases my chances a lot, right? 1 over 720 is a lot better chances than 1 over 50, 40. Okay, and it's only one extra book because there's just that many more combinations. Okay, make sense? But we're using all 7 books, or we're using all 6 books, so it's like NPN basically, or NPR with the same number. Got it? Beautiful. All right, we're gonna stop there because it's Friday. Monday, we will do the rest of this review. Yeah, yeah. All right, goodbye.